Hey guys, this is Adarsh. Along with me, there is Rohan and Punit. So before moving on to the presentation, I will be giving you the small analogy. So as the days glide and like a passing cloud, we come across various streams of new and existing problems to be solved. So main equation for the life is equal to the problem solving. So to move on the life, we need to solve each and every problem which has been occurring. So one such profound problem today we'll be going through is that is diet problem. So diet problem, we have come up with a theme called as optimizing your diet approach towards the health. So before starting my presentation, I would be giving you an excellent quote by one of the greatest philosopher of the ancient technology is Chanakya. Chanakya says, as long as your body is healthy and under control, the death is distant. So let me introduce you towards the diet problem. So we are bringing you the groundbreaking solution that harness the power of optimization to revolutionize your eating habits. And we are getting ready to embark on a journey where the satisfaction of optimization meets the wonders. So let's all thank wherever the optimization given us the opportunity. So to solve the diet problem, we are using major technologies of optimization like linear programming and genetic optimization algorithms and particle optimization, that is PSO. So these are some of the algorithms that we use to solve the diet problem. So moving on to the problem statement. So the problem statement mainly focus on maximizing the calories and minimizing the cost, which in turn improves our health. So the diet problems involves an effective and personalized diet plan which aims to achieve weight loss or any diet issues. So the major objective is to ensure and overcome the challenges like nutrition, calories, and portion of the control of the food choices. So next, coming on to the challenges. So we have numerous and external problems such as caloric deficit. So the diet plan should be involved in caloric deficit with which promotes the good health and which has the full balance and intake of the food contents. So next, moving on to the nutritional adequacy, the diet plan must meet the individual nutritional needs and providing a wide range of essential nutrients. So next, moving on to the portions and the control, because entire diet needs to be having certain portion things. So the diet plan should have guidelines for each and every sectors for how much portion of sizes we are consuming the whole or unprocessed foods. So to do this projects, we have done some critical analysis and synthesis wherein we have observed many scholarly articles. One such article is The Guardian. It's one of the British newspaper where the 25 food firms have been combating health diets. So we are doing some critical analysis on these subjects, including some business cider informations and case study on the General Motors. So extensive research of a literature survey of this project mainly depends on the newspapers or scholarly articles, out of which we have bringing an layout for you people. So one such layout is the first layout is the obesity and public health. So the newspaper which I early suggested to everyone, that is Guardian. So it offerly discuss about the global obesity and epidemic things and public health. They explore the role of unhealthy diets, excessive sugar consumptions, and processed foods, and contributing to the weight gain and related health issues. And secondly, it focuses on sustainable and plant based diets. The newspaper covers the growing interest in sustainable and plant based diets, that means to address the concerns and improving the health.
Diet plan was launched as a part of health program in 1985 for employees of the General Motors Corporation. The primary aim of the diet was to enhance the overall quality of workforce in addition to improving the health of the employees and their families. It is a weight loss plan that claims to help you lose around 10 to 17 pounds in just a week. The GM diet is based on the principle that the foods you consume will burn a greater number of calories than they provide for your body. Next slide. Here is the 7-day plan given by the GM. Day 1. Day 1 is a fruit day where you consume only fruits. The fruits recommended are apples, orange, berries, watermelon, etc. Day 2. Day 2 is a vegetable day. Day 3. It is a combination of fruit and vegetable day. Day 4. Day 4 is where you can consume banana and milk. Day 5. Day 5 is a protein day where you consume protein rich foods like meat, etc. Day 6 and 7 is meat and vegetable day. They include meat or protein rich alternatives. Now I will show you the detailed diet plan. Yeah. Day 1. Day 1 is fruits only diet. Here you can see the breakfast, snack, lunch, snack, dinner, etc. recommended by GM. Day 2 is vegetables only. Day 3 Day 3 is fruits and vegetables. Day 4 is bananas and milk. Day 5 Day 5 Day 5 is meat. Day 6 is meat and vegetables. Day 7 is rice, fruit and vegetables. We saw the General Motors diet plan. Now, in India, there are number of vegetarians are high. So, it is recommended to eat paneer, cheese and other foods which are rich in protein instead of red meat. It is mandatory to drink at least 8 to 12 glasses of water a day. Wonder soup. Here is the Wonder soup ingredients, and it is a low calorie soup that uh, that provides low calories, and it is a key component in your diet. It is a diet which is included in day 4, 5, 6, and 7. Typically, people tend to lose weight in their first 3 days as calorie intake is just 1000 to 2000 a day. It is a low carb diet plan, so yoga, workout, and other exercises are also recommended. Now, foods to avoid: bananas, potatoes, and etc. are avoided because they increase your weight. Now, oil foods like junk food, etc., are also not recommended. Sugar foods and carbonated beverages, alcohols, are also not recommended. Now, coming to the advantages. As the intake is of only healthy food like fruits, vegetables, they are also rich in high fiber. It also improves the bowel movement and boosts the metabolism. The diet plan has no fried items and junk food. There is also no sugar intake, and the only sugar intake is from fruits, that is fructose. Now coming to the disadvantages. Disadvantages. It is not a long-term plan, and it is a not a sustainable weight loss solution. It is deficient in several vitamins, minerals, and other nutrients. This diet may fail because it requires eating the same food in one day, and it is difficult for those who prefer variety in their meals. This diet plan has also caused many health issues to many people, those who have followed it. Health issues like letharginess, tiredness, and fatigue, muscle weakness, dehydration, headaches, etc. Now, finally, would you recommend this diet plan to everybody? No, certainly not. It is not recommended. It can harm your health in a long run. It weakens your immunity, causes weakness, and can lead to other health problems. So, what is the solution? The solution is to eat a balanced diet every.
I will be discussing the rest of the topic like gap analysis, implementation, and interpretation part. And we will be ending up this particular presentation by giving a summary or the conclusion. So firstly, I will be discussing about the gap analysis, which basically describes the level of complexity as well as the necessity of the problem to the real world. So firstly, I will be discussing about the level of complexity. The level of complexity in the diet problem can vary depending on the specific objectives, constraints, and the consideration taken into account. Here, the objectives are nothing but the resources that has to be taken into our diet, and the constraints are how much amount of resource has to be taken into our diet. So in its simplest form, the diet problem may involve optimizing the intake of certain nutrients by minimizing the total cost of the diet while meeting a specific nutrition requirement. This is what the problem statement which was taught by my friend Adarsh. So which basically tells that we need to minimize the total cost by maximizing the objectives of the nutrition resources. So however, as more factors are incorporated, such as individual dietary preferences, food availability, cultural consideration, we can say that the complexity of the problem may increase or may not increase. So depending on the current situation, we can say that the complexity of the problem is increasing. So next, The next, I will be discussing about the necessity of the problem to the today's world. So in today's world, the diet problem is of significant importance due to several reasons. So I have listed some of the reasons like health and nutrition, food security and food system, personalized nutrition, long-term sustainability. So overall, I can say that as the complexity of the diet problem has been increasing day by day, and its necessity to the real world is been increasing the day by day. So it is required to have an optimized solution to address health concern, promote sustainable food system, ensure food security, and also to personalize nutrition guidance. So this completes the topic of gap analysis. Let us move on to the next topic of discussion, that is implementation and the interpretation. So as I already suggested, we should have an optimized solution or the optimization technique to solve the problem. So I have listed some of the optimization techniques to solve the diet problem. Like we can solve the diet problem by using linear programming technique, particle swarm optimization technique, genetic optimization technique. So as we are familiar with linear programming technique, so we have took an instance of the problem of the diet problem and we have solved that by using linear programming technique. So let me show the instance of the diet problem. So this is the instance of the diet problem. Let me read out the question. So our dietitian has developed a special diet using a 2 food P and Q. So here we have a 2 food P and Q, and the dietitian has to develop a special diet using this food P and Q. So each packet of food P contains 12 units of calcium, 4 units of iron, and 6 units of cholesterol. The resources that we have considered here is the calcium, iron, and the cholesterol. So food P contains 12 units of calcium, 4 units of iron, and 6 units of cholesterol. And the same quantity of food Q contains 3 units of calcium, 20 units of iron, and 4 units of cholesterol. So here we have listed the requirement of the nutrition resources in our diet. So our diet requires at least 240 units of calcium, at least 460 units of iron, and at most 300 units of cholesterol. So the main agenda of this particular problem is to find the how many packets of each food should be used to meet essential nutrition requirement in a diet by minimizing cost of the diet. So and we need to find the minimum cost of the diet. So let me move on to the solution part. So here you can see the table, which is a simplified version of the question. So you can see there are basically 2 foods, that is food P and Q, and the resource has been listed here, that is the calcium, iron, cholesterol. So food P contains the 12 units of calcium, 4 units of iron, and 6 units of cholesterol, whereas the food Q contains the 3 units of calcium, 20 units of iron, and 4 units of cholesterol. So the requirement in our diet is that at least 240 units of the calcium is being required, and at least 460 units of the iron is being required, and at most 300 units of the cholesterol is being required. So in order to solve this particular problem, we have made an assumption that that X basically represents the number of packets of food P, whereas the Y represents the number of packets of the food Q. As the main agenda of the problem is that we need to minimize the cost. So the objective function is the minimization, that is minimize Z equal to 6x plus 3y. This is the objective function. So subject to the constraints. So these are all the constraints which is basically derived from this particular table itself, like 12x plus 3y greater than or equal to 240. When we divide the whole equation, that is whole linear equality equation by 3, we get this particular equation, that is 4x plus y greater than or equal to 80. Similar to that, from these two, that is iron and cholesterol row, we have derived this particular constraint, that is x plus 5y greater than or equal to 115 and 3x plus 2y less than or equal to 115. And the non-negative constraint is being given as x greater than or equal to 0 and y greater than or equal to 0. So in order to solve this particular linear programming, we have lots of techniques, like we can solve this particular problem by using graphical method. We can solve this particular problem by using simplex, 2fx, as well as the big M method. But we have solved this particular linear programming problem by using the graphical method. So we have taken a graph where x-axis represents the number of packets of food P and the y-axis represents the number of packets of the food Q. And we have plotted the constraint, the first constraint, that is 4x plus y greater than or equal to 80. And we have plotted the second constraint, and we have plotted the third constraint as well. So the resultant graph something look like this. So you can see here the constraint number 1 is being plotted here, and the constraint number 2 is being plotted here, and the constraint number 3 is being plotted here. So the feasible region that we have obtained here is this. So let me talk about the corner point that we have obtained. The corner point, that is A, B, C. That is A is of 15, 20 coordinates, and B is of 2, 72 coordinates. C is of 40, 15 coordinates. So from this we have derived the optimal solution. These are all the corner point, that is 2, 72, 15, 20, 40, 15. When we put this particular coordinates to the maximize, that is the minimize objective function, that is z equal to 6x plus 3y, we obtain the solution as value of the Z as 228, 150, 285. As the agenda of the problem says that we need to minimize the cost, so we need to consider the minimum among this particular Z value. So we have took the the minimum value among this is the 150. So we have took the 150 value. So we have derived the conclusion by stating that the cost will be minimum by meeting necessary nutrition if and only 15 packets of food P and 20 packets of food Q are used. So thus the minimum cost will be 150 rupees. So this completes the solution part of this particular problem. The same problem we have solved by writing a piece of Python code. So implementation of the same by using Python code. So let me show the particular code. So yeah. So here you can see the code. We have imported the bulk model. From that, we have imported these following functions, and we have imported the warning. And from the warning model, we have imported the simple filter, which basically ignore the Python interpreter warnings. So here you can see we have included the objective function. Then we have included the constraints. That is first constraint, then second constraint, and the third constraint. This particular line solves the particular problem, and this particular line gives the x value. This particular line gives the y value, and this particular line gives the objective function value. So this particular things brings the x and as well as the y as well as the objective function value. So let me run this particular code. So here you can see the solution. The optimal solution that we have obtained here is x equal to 15, y equal to 20, and the objective function is 150. Let me cross check this. So here you can see the corner point is 15, 20. That is what we obtained here. 15, 20, and the value of the z is 150. That is what we obtained here. That is the objective function value is the 150. So here we have obtained the optimal solution. So in order to do it by graphical method, so we have used a software simulator which is called as a Tora. Before opening that particular Tora to implement this particular problem graphically, let me show the input text file. So here you can see the input text file. So the objective function is the minimization. So we have written the minimization, and these are all the decision variable, that is x and y. This is the coefficients of objective function, that is 6 and 3, and this is the this represents the constraint number 1, this represents the constraint number 2, and this represents the constraint number 3. So let me load this particular input file, and let me obtain the solution in a graphical way. So wait a second. So this is the Tora software that we have obtained. So here you can see that we need to select the existing file. So I have clicked this particular button. So here I will be selecting the existing file, that is input.txt. This is the input for the particular problem. So yeah, let me solve this particular problem. So now here you can see the graph. So let me plot the first constraint. So this is how the first constraint looks, and the second constraint, this is how second constraint look, and the third constraint, this is how the third constraint look. And this is the optimal solution. This is where dotted mark has been put it. So this is the feasible region. So let me plot the objective function as well in order to obtain the optimal solution. So here you can see the line represents the optimal solution, and here you can see the description where the x1 value is the 15, which I have assumed as x, and x2 value is 20, which I have assumed as y. So this is the objective function value, that is 150. So that's what we have obtained by doing manually. So here you can see that the corner point is 15, 20, and the objective function value is 150. Wait a minute. So finally, we have seen the solution of this particular problem by using graphical method, where we have implemented by using software simulator, which is called as Tora. So we have come to the end of the presentation. So I will be concluding this presentation by giving a summary part. So in summary, what can I tell you that the problem statement is so simple, the diet problem. So the problem statement states that we need to minimize the cost by maximizing the objective values such as nutrition requirement, that is the resources like calcium, iron, cholesterol, what we have took in the example. And my friend Rohan have taken a beautiful case study regarding GM, that is General Motor, which basically use a diet plan. So finally, I will be saying that the optimization technique, what we have listed in the previous slides, that is the LB and the genetic algorithm and the particles from techniques. Three of them can be useful. It basically provides a valuable tool for addressing diet-related challenges, improving nutrition, promoting healthier eating habits at both the individual as well as the population level. So this completes the end of the present. We have come to the end of the presentation, and this completes the presentation. On behalf of my team members, we thank Rohit sir for giving this particular opportunity. We have learned from a lot from this. So we end this particular presentation.